Okay, this is going to be a video on statistics for Algebra 1. This is the first video. I want to talk about these keywords. Mean, which means average, okay? All right, so if like you take your average of your summatives, you add them up and divide by how many there are. All right, how many, okay? And you probably learned about that in the past. Standard deviation is basically how consistent you are around the average. Okay, let me see if I got let me talk about this concept, okay? Let's say you were selling shirts, okay? Both people, if you added these up and divided by 4, you would get the same mean of 40, okay? All right? But who is more consistent? And what consistency means is who is closer or closer to their average more often. Well, as you can see, this person's got a big fluctuation. So person B, all right, is actually more consistent. I mean, they're going to have a lower standard deviation, okay? All right, why does consistency matter? Okay, so consistency can matter for a couple things. If you're in sales, do you want a salesperson, do you want to sell periodically up and down, or would you want to have consistent numbers? Well, I would want to have consistency, okay? So what standard deviation means is consistency around the average. The lower the standard deviation, all right, the more consistent, okay? All right, the lower the standard deviation, the more consistent. Now, what you can also do is you can use something called a z-score. And a z-score is whatever your data point is minus your mean divided by your standard deviation, okay? And basically what happens is z-scores, okay, lead to what they call something called normal distribution, okay? And it can help you figure out probability, okay? And this normal distribution ends up being what some people would call a bell curve or a normal distribution curve, okay? All right? And the way a normal distribution curve means is within one standard deviation, about 68% of the time, your data will be in there. Between 2 standard deviations is 95.44, and then between 3 standard deviations is 99.72. These things outside are really outliers, okay? So you need to know sort of these amounts, okay? All right, this is within 1 standard deviation. This is within 2. This is within 3, okay? All right? All right. Now, let's talk about how you calculate probability, okay, with your calculator, okay? All right. All right. And if you have a Casio, which I'll show you these steps and we'll go back over, but if you want to take a picture of these, all right, you go to menu, you go to stats, okay, and select that. I select dist, which is F5, normal, which is F1, NCD, which is N2, okay. Some of you guys will have at the top of your calculator variable. Make sure you've selected that. And then you put in your upper, which we'll talk about in a second, your lower. The little curve thing, that's your standard deviation. And that thing is your mean, and you put that in. If you're using a TI, you hit second bars, normal CDF, lower, upper, put your standard deviation, which is the same thing, and your mean, okay? All right. So let's talk about some examples. Okay, so let's say we were looking at SAT scores. So what the normal distribution thing says is it helps you figure out what is the probability that a certain amount will fall within that z-score. So greater than 1200, what does that mean? Okay, so at 1200, greater than would be, what is the probability that this is happening? Okay, so how would we set that up? Okay, so if we were at this point, okay, my lower amount here would be 1200. So I'm gonna do a little mini thing. And it's greater than, so that's gonna be, I'm just gonna put, it's basically infinity, okay? All right, so it goes that way. So my lower, I'm gonna put 1200, okay? My upper, I'm just gonna put a bunch of ones and zeros, all right? Okay, mean is 1,000, okay, so that's that. And standard deviation is 200, okay? What does that mean? The average SAT score is 1,000, and the standard deviation is 200, okay? And if I hit execute, it tells me the probability is 0.1586, okay? All right, so that's about, if we'll talk about percentage in a little bit, that means that about 15%, if you multiply that number times 100, of students are going to score greater than 1,200 on SAT, meaning 85% would score less. Greater than 900. So I make my little curve, that's 900. Greater than would be all the way here. So that's the area under the curve. Okay, I'll hit X to go back. So my lower is going to be 900, and my greater is going to be those thousands, those are going to be the same. And so the probability is 0.6914. Okay. Now, between 1,100 and 1,350. So what that's going to be, 1,100, 1,350, between those, okay, would be that amount, okay? So when I go back in now, my lower amount is 1,100, my upper amount is 1,350. Same standard deviation, same mean. 0.2684 would be the probability that somebody's SAT falls in that range. Less than 1,500, okay, so here's 1,500. Less than would be this way, so that's going to be negative infinity. So the thing that's going to change in this lower amount is I'm going to put negative like 1,000. I'm going to fill up that with zeros. Okay, my upper is 1,500. Same mean, same standard deviation. Okay, so 0.9937. Okay, that's the probability someone's going to score. What does that mean? 99% of the chance somebody's going to score less than 1,500. All right, less than 1,050. So 1,050 is right here, going this way. So that's going to be negative infinity. Okay, all right, 1,050. Okay, 0.5987. Okay, that's the probability. All right, less than 700 or greater than 1,100. So here's what I got. I got 700 going this way. I got 1,100 going this way. Okay? So what I'm going to do is I'm going to figure out the negative one first with the 700. All right, that's 0.0668. 0.0668. Okay, that's that way. Now the other way, my low thing would be 1,100, and that would be infinity. Okay, all right. So 1,100 would be the low one, and then I'd put a bunch of zeros in there. You can use 9. Just put a really big number. Okay, that's 0.3085. Okay, so if I add those two numbers up, okay, I go back into this screen and go 0.0668 plus 0.3085. I get 0.3753. Okay, what is the probability that'll be less than 900 or greater than 1,500? So 900 this way, greater than, all right, 1,450 this way. So that one's infinity, that one's negative infinity. Okay, so let's go back into menu and stat, dist, norm, NCD. The data is still there. Okay, so we'll put the upper 1,450, and that's infinity. So I got 0.0122. Okay, and then I'm going to switch that up and put negative 1,000. Okay, with the upper being 900. All right, 0.0385. Well, that's weird. That was exactly that same thing. Okay, so I would want to add those two. Plus 0.0122. So probability is 0.3207. Let me just double check this one back here. This 1500 that I was good. I didn't make a mistake. Okay, dist, norm, NCD. I just want to check this one, 1500. Yeah, that's right. Okay, so that's how you figure out probability. Okay. Now, let's talk about probability. Probability is a decimal-based answer. So 2, 3, 5, 7, that's the probability. Okay? The percentage is you take your probability and you multiply by 100. If they say, what's the probability that 500 people do it? You take the probability and multiply by the number of people or items. Depends on the situation. Okay? All right, so an airline finds that the travel time between two cities has a mean of 85 and a standard deviation of 8. So we're going to go ahead and write that. Mean of 85, standard deviation of 7. That means that's the consistency. Okay? What is the probability a flight will take longer than 95 minutes? So if I'm doing my curve, I have 95. All right, longer would mean greater than. Okay, so we go into here. Okay, I got to change some of this. The standard deviation 7, mean is 85. Okay, all right, since I'm going this way, that's going to be 95, and then the positive infinity would be the other way. Okay, all right. All right, probability is 0.0765. Then it says, what percentage of flights take between 75 and 95 minutes? So between 75 and 95 would be this, okay? So let's go back into my problem, make 75, 95, okay? My probability is 0.8468. Now, since it says percentage, I multiply that by 100, okay? 0.8468 times 100, that's 84.68%. That's the percentage of time, all right, that flights are between there, okay? All right, if there are 200 flights to the city on a given month, how many flights are going to take longer than 100 minutes, okay? So here's 100, longer than means this way, okay? So I would have the infinity here. So let's go back into menu to stat, dist, norm, NCD. Okay, my lower is 100. This is going to be one of these big numbers here. Okay, I got 0.0160. 0160. So they're saying there are 200 flights. I'm going to multiply by 200. Okay, so 200 times 0.0160. That's 3.2 flights will be longer than 100 minutes. Why is that important? In the FAA, you get fined by a company if you're fined by the government if your flight consistently is they're not booked on time. You can also have to refund passengers money. So that kind of information, well, how many flights, you start going into that likelihood. So that's basically importance of normal distribution. Okay, a certain type of hybrid SUV averages 36 miles per gallon with a standard deviation of 3 miles per gallon. All right, that's a gallon of small, spelled incorrectly. Okay, all right. So we're going to sort of practice these together, but I'll just go through these examples with you. What percentage gets more than 40 miles per gallon? Okay. All right, so 40. Okay. All right. Would be this. That'd be negative infinity. Okay. Our mean is 36. Standard deviation is 3. Okay. All right. So menu stat. This norm NCD. Okay. My lower is going to be the negative infinity. Okay, my upper is 40. I have to change my standard deviation, which is 3, then 36. Okay. All right, so the percentage, okay, first the probability is 0.9087. So what I want to do is multiply by 100 because it says percentage. That's going to turn out to be 90.87%. What is the probability? It will be between 38 and 50. 38, 50. All right, that's the area I want. So all I would do is I'd go in and change 38, 50. And that's 0.2524. Okay, now since it's saying what is the probability, I'm good with that. If 1,500 cars are made, how many will get less than 30 miles per gallon? So 30. Okay. Oh, whoops, this one's not right. Hold on. Sorry, let me back up real quick. That's not correct. I did more. I should have done the other way. Hold on. So let's go the other way. Let's erase this. Sorry, I got ahead of myself on that one. That would be 40. And then, all right, 0.0912. And 120, wait, 0.0912 times 100, okay, would be 9.12%. And ironically, that goes opposite of the other one because think about it, the whole area is 100%, okay? So less than, so this one would be the negative infinity one. Sorry about that. So let's go ahead and make that the negative infinity one for the lower. Okay, the upper is 30. Okay, so I got 0.0227. 0.0227. And since I have 1,500 cars, I want to multiply that by 1,500. That's 34.05 cars. Okay, so about that many cars. Okay, what percentage of cars is less than 31 miles and greater than 42? So what I got is I got 31 miles that way, 42 this way. So what I want to do is I want to figure out what the probability is. My unit stat, dist, norm, NCD. All right, I'm going to do this one first with 31. Okay, that's 0.0477. I'm going to add that to, okay, now I go back in there. All right, the upper now is the positive infinity. Okay, the lower part is 42. Okay, so that's 0.0227. 227, yeah. All right, so I want to add those two. Okay, so 0.0477 plus 0.0227 gives me a total of 0.0704. I want to multiply, since it says percentage, by 100. So I'm going to multiply that by 100. Gives me 7.04%. Okay? So, all right. So we're going to go ahead and try this one, okay? Go ahead and try this one on your own, okay? All right. You can practice that one, okay? All right, and we'll go over that in class, okay? All right. And then there's an additional worksheet for you to practice, okay? But the idea behind this, okay, is when you have data that's normally distributed, okay, most of the data, okay, all right, we're looking at how consistent, okay, so in the normal curve, in the middle is the mean, okay, all right, how consistent, okay, all right, is your data, all right, is it below the mean, is it above the mean, how much? And over time, if you track lots and lots of numbers, okay, all right, you'll learn about this if you take statistics, is that the data will predominantly fall between, one standard deviation, 2 or 3, okay, and it forms a bell curve. There's more data around the mean than there is on the outside. You see that with a lot of things in society, okay? So that's the first lesson on statistics. Okay, we're going to get into regular probability of certain events. All right, now these are of a number of events taking place. Okay, a lot of data will make up a normal curve.